Okay, everyone, let's do some more Pascal's triangle and expanding these binomial powers. Here we go. So this one we're actually going to do everything because they didn't ask for a first term or coefficient of term, which we'll do in another video. So first of all, let's go ahead and start out by doing Pascal's triangle. Remember, it always starts with 1, and the beginning and end of each row is a 1. The only numbers that change, of course, are the numbers in the middle. So why did I get the 2 again? Because 1 and 1 is 2. And so when I go to my next row, I'm going to have 1, 3, 3, 1, because 1 and 2 is 3, and 2 and 1 is 3. And I'm going to go to 5 just to go a little bit further. And if I need to go further than that, then I will, of course. But the next row is going to go 1, 4, 6, 4, 1. The 1 and 3 make 4. The 3 and 3 make 6. The 3 and 1 make 4. And we'll do one more. 1, 5, 10, 10, 5, 1. Now, in problem 56, notice it is a 3 power. So therefore, we're going to use this row with the 3's in it. It's that simple. So I'm going to start by writing down 1, 3, 3, 1. I know that with the x in front to the 3rd power, I'm simply going to get, sorry about that, someone had their annoying car alarm go off. All right, so as I was saying, I know x will have a 3 power on it. So I'm just going to go x3, and I'm just going to count down, right? x2, x1, x0, of course, x0 simply 1. The only tricky part potentially is a -4. Note it's a -4, not a +4. So it's going to go -4 to the 3, -4 to the 2. See how I'm counting backwards? -4 to the 1. And we know this happens, guys, because it's all based on patterns. Okay, it's not magic. And, of course, anything to the 0 power is 1. So now I'm ready to finish my expansion. In the first term, I have 1 times x3 times 1, which is simply x to the 3rd, or x cubed. In the second term, I note that I have a 3 times a -4, which is a -12, x squared. In my third term, note that -4 squared is actually 16. So 16 times 3 is a positive 48. Watch your signs, guys. X. And then finally, in my fourth and last term, I have 1 times -4 to the 3, which is going to be a -64. -4 times -4 times -4, in other words, is -64. This is the result, guys. If I actually took x minus 4 to the 3 and multiplied it out 3 times, like so. So keep that in mind, that what we're doing is a quicker shortcut once you learn how the pattern works. It's all based on patterns. Okay? So guys, go ahead and pause the video and try number 57. Okay, how did you do on number 57? Notice it was a 4 power, so therefore, we're going to take the row with the 4 in it. See the 4's right here? That gives away that it's the 4th power row, as I like to call it. 1, 4, 6, 4, 1. So I'm going to start out by going 1, 4, 6, 4, 1. Now the 4y starts out with 4y to the 4. Then 4y to the 3, 4y to the 2, 4y to the 1, and of course 4y to the 0 is going to be 1, right? The x will also have a 4 power, but go backwards. X to the 4, x to the 3, x to the 2, x to the 1, and x to the 0 is simply 1. So we're almost home free. Okay guys, I just popped in a picture from my calculator. So finishing up here, note that if I do the first term, I'm going to end up with 4 to the 4. Looking at my calculator, you can see that's 256. So I'm going to end up with 256 y to the 4. Again, x to the 0, just simply 1, right? Plus, in my second term, note that I have 4 to the 3 times a 4. And as you can see, 64 times 4 is 256 again. So I have a 256 there. Don't forget there's a y to the 3 and an x. So if we go alphabetical, I'm just simply going to say x, then y to the 3rd power. In the third term, note that I have 4 squared times a 6. And 4 squared times a 6, it's not on the screen, but 16 times 6 is 96, okay? But hopefully you're seeing, feel free to use a calculator on these. So I end up with a plus 96. Note that's a y squared and an x squared. So alphabetically, I would say x squared, y squared, 96. X squared, y squared. In my fourth term, I just simply have 4 times 4. So I have a plus 16. Y1 with an x3. So I'm going to say x3y, putting the x alphabetically before the y again. And then finally, I have 1 times x4, which is x4. This, guys, again, is a result of me taking 4y plus x times 4y plus x times 4y plus x times 4y plus x the 4th time. Okay, so understand it's a shortcut. All right, pause the video. Let's do one more problem, number 58. Try it first, please. Pause the video and try it. Okay, let's see how you did. Notice it was a 3 power. So according to Pascal's triangle, again, in case you forgot, right here, right? 1, 3, 3, 1. So you should have started out with 1, 3, 3, 1, right? And the x to the 3 is going to go x3, x2, x1, x0, of course, is 1. Then the 2 to the 3 is going to... Sorry, got interrupted by a phone call there, guys. So finishing up, we did the x's, so now we're going to do 2 to the 3. So remember, it's just going to count backwards. We don't really need the parentheses since there's no negative to worry about, okay? But of course, 2 to the 0, of course, is 1. And now, finishing up, I know my first term is simply x3, or x cubed, right? I know my second term is going to be 3 times 2, which is 6x squared. My third term, note the 2 squared is a 4. So 4 times 3 would be 12x. And finally, 1 times 2 cubed is simply 8. So the only tricky thing about these, notice, guys, is when there's that darn negative in there. And remember, when you have an odd number of negatives, it's always going to end up being negative. Even amount of negatives, of course, cancels out the positive results. But that's it for this second video on binomial expansion or Pascal's triangle. It's technically my video number 4. I'll see you in class.